Ready to Observe is a whole series of activities and demos to help you prepare your visitors for their telescope viewing experience. Do your visitors sometimes expect to see images like these in the telescope? Looking at the moon and planets may show this kind of detail, but things outside our solar system, out in the realm of the stars, nebulae, and other galaxies, are very far away, and only a little of their light is reaching us. Our eyes work very differently from a camera that would produce photos like these.
I'll demonstrate the use of the color and averted vision card. This card can be used at night at the telescope or in a darkened room. Of course, to shoot this video, we require a lot of light, so in the video you will not see what you would see with your eyes in the dark. Please consider this only a demonstration of how to use the card. First, let's look at the color side of the card. We're looking at a distant galaxy called the Whirlpool Galaxy.
I thought I'd see more color.
Most of the pictures you see in magazines are in color, so it might be disappointing not to see much color in the telescope. Our eyes just cannot detect much color in dim light. Here, can you tell me what colors these squares are? When we look through the scope, for the most part, our eyes only see shades of gray. What colors do you see?
Mostly gray. There might be some green.
Okay. Now what colors do you see?
I see blue and red and some yellow.
We don't have as many color receptors in our eyes as black and white receptors. Also, our eyes' colors receptors are not as sensitive. We need a lot of light for our eyes' colors receptors to detect any color at all. When we look at dim objects that are far out in space, there is so little light reaching us that only our black and white receptors can detect the light. Take another look.
That galaxy sure is dim. It looks just like a fuzzy patch.
You're right. Only a little of its light is reaching us. Let me show you a way to use the part of your eye that is most sensitive to light so you can see more detail. We'll use a technique called averted vision. It's really easy. Close one eye. Look directly at the galaxy image in the middle. Now, look at the black dot away from your nose. I see that your right eye is open, so you would look to the dot on the right. The image might appear to be a little brighter, but the effect works better in the telescope. When you look into the telescope eyepiece at the dim object, look to the side away from your nose, about as close to the object as this dot is to this photo. The object you're viewing will appear brighter, and you'll see a little more detail.
That is better.
This is important. If you look in the direction of the dot toward your nose, you are centering your eye's blind spot over the image, making the object disappear. Avert your vision in the correct direction, away from your nose.
Let me show you another very handy card. The Field of View card allows your visitor to see how much of the sky your telescope is looking at, how much of the sky they're seeing in the eyepiece. Hold this card at arm's length. Close one eye and look through this hole that says Backyard Telescope. That's how much of the sky you can see in many telescopes at 70 to 100 power, about half a degree. The rest of the holes represent the field of view of various space-based and ground-based telescopes NASA uses to study the universe. At the telescope, hand it to your visitor, have them hold it at arm's length, and point to the area of the sky that you're looking at. Have them frame the hole over that area, and they'll be very surprised, most likely. Some won't believe you. Try it on a terrestrial object. You can also prove it to them using the moon. Ask your visitor if they think the moon will fit in the half-degree hole. They'll probably say, "No way." Then, have them try it with the card. It is the same field of view when they look in the scope.